learn how to create GitHub Profile Analyzer using Google Gemma?
Hello, curious student. So today we are going to understand GitHub Profile Analyzer tool which I have built, and we are going to understand the entire code, how the model selection process works, and so on and so forth. But before we proceed with any of that, let me just give you a quick demo of what we have built today. So this is a GitHub Profile Analyzer, and we need to add a GitHub username. So I am using my own GitHub profile, and I am copying my username here, and I am pasting it into my GitHub Profile Analyzer, and I click on Analyze. And in some time we will see the analysis of my GitHub profile. Now this analysis is built using Google Gemma model and some data science tools as well. So that's there. So this analysis is now ready, and as you can see we have the analysis which is generated in Google Gemma model. Let me just zoom in into the window. So this is my GitHub profile URL. This is the profile image which is fetched from GitHub API data. Now the analysis that you see here is generated 100% using Google Gemma model. So this is the overview with Google Gemma model generated using the data which we provided it using the GitHub API call, and the data from which we got from GitHub API is been inserted into Google Gemma model, and this is the final output. So this is the overview of my profile. Then the main technologies which I worked on, which is pretty impressive. Then the development patterns have also been generated by Google Gemma model, and the overall suggestions or the contributions of my open source contributions and other stuff has also been generated. So this complete analysis is generated using Google Gemma 1.1 model. Then we have a table which contains all the repositories, the top repositories which I have based on star count, and these repositories are the top 10 ones from the 89 repositories which I currently have. So the top 10 repositories from that on the basis of star count are added here. So this table is generated using pure Python code, and I'm using Gradio for user interface, which we will see in some time. Then we have a data science analysis. So we have a word cloud based on the topics which I generally use in my repo descriptions. Then these are the top 10 repositories again which we just saw. So let me just zoom out a little bit. So these are the repositories which we just saw in a graphs bar chart way, and we also have the language distribution. So majority of the repos are created using JavaScript, and a few of them are created in Jupyter Notebook using Python, and one is using HTML, and if you see there is one from created using Vue.js as well. So these are the top 10 repos which are shown in the form of a bar chart. Then we have a repository language distribution, as you can see. So the main languages which I use are displayed here in the form of a pie chart. And we have a repo creation timeline. So this shows us the time when my repos were created. As you can see, from 2020 to 2022 I was most active on my GitHub profile, and here you can see that at a time I created around 18 repos in a specific time period, and then rest of the time I created some repos. So this is the repo creation timeline graph as well. Now let's just quickly jump into the code and understand how this is created. So let me just come back to the presentation. So we are going to understand the code behind this, and we are going in these steps. So we are not just jumping into the code, but we are going to end-to-end process which will help you to generate LLM based analysis along with data science tools based analysis on any topic. So we already covered quick demo, and now I am jumping into the model selection part. Now coming to model selection, I am using Google Gemma model here, right? So this is the official website of Google Gemma, and here you will find the various types of Google Gemma models that we can use. So there is TX Gemma, then Shield Gemma, then Pali Gemma, and Data Gemma, and other stuff. So these are the types of Gemma models. So this official website has tons of resources by which you can use the Gemma model. I am using the Gemma model from Hugging Face website, which we will come to. So there, these are the four ways in which we can use Gemma model in our projects, which is using Hugging Face, then using Keras, using Olama, and then Gemma Python library as well. So the documentation, if you see, has tons of resources which you can use to actually create the code in a better manner. And if you go into the Run Gemma section, you will see that from the Hugging Face transformers which we have just used. So the colab code can be generated from here or used from here. Then the Olama and other types can be added here as well. Now coming to the Google Gemma model on Hugging Face. So this is the official Google company organization which is present on Hugging Face, and as you can see we have tons of models here, around 35 collections, which a lot of models. From that I am using Google Gemma 1.12b. Why 1.1? Because I had some memory constraints when I was running the model on Google Colab, and I wanted to make sure that the model was as resource optimized as possible. That is why I used Gemma 1.1 instead of the latest Gemma 3. Now, if you want to understand which model will take how much memory, the most easiest way to do that is to analyze the safe tensors part in the files and versions section here. So this model has around 4.95 GB of a safe tensor and then 67 MB. So less than 5 GB. And based on this, the memory footprint can be understood. Now, initially, like when I was like trying to create a memory optimized version, I did not directly jump into Gemma 1.1. I actually used the Tflan 5 model, which is the most lightweight model in the Google series. So I used the T5 series, and T5 output wasn't great, which is why I jumped into the Gemma model again. And if you see the files and version, you can see that it is just around less than even 1 GB. So around 892 MB of space of safe tensor. So this is the most memory optimized model, but the output wasn't the way which I wanted to. So that is why I first tried around with T5 base. Then I also tried using BERT model, but that failed. Then I initially I used the Gemma 3 model, but it was highly resource intensive, and like I did not want that amount of resources to be used. So if you go into the files and versions, you can see that it is like the safe tensors part is 2 GB, and then the tokenizer model. So you can use the Gemma 3 1B as well, but for the sake of generation, I currently used Gemma 1. Now Gemma 3 can also be used. Gemma 3 is the latest model that we can use, and Gemma 1.1 is the next series of models. So let me just stop my GitHub collab first so that we can jump into the other part. Now, you can also use the Meta models as well. So Meta has a Llama generation models which you can use as well, like Llama 4 series, Llama 3 series, and other models that are currently present in the Meta Llama series. You can also use them as well. Now, before you use this model, you have to make sure that you have access to those models. What I mean by access is when you go to the model card of this model, you will see that this is a gated model. What I mean by that is you need to sign a agreement that you will use this model responsibly. So on a Hugging Face, you first need to create an account and go to the Google Gemma series model, and you need to like acknowledge that you are going to use this model for safe and responsible way, and acknowledge the like readme agreement. Then you will be granted access to this model. So access to Google Gemma models is quick. For Meta, it takes some time, but once you like fill in the agreement, you get the access to the models. So this is the agreement which I was talking about. Once you sign in into this agreement, you get the model, and based on the model requirements, you can sign up to different model requirements and get the access. Now there are another way in which you can use the model on your Google Colab, and that is using Keras as well. So depends on your preference. You can either use Keras to run the model, or you can use Hugging Face, or you can even use the official Gemma library as well. Depends on your context. So whichever way works best for you, you can use that. Now that was the model selection part. Now this is the model selection which I just went through. So whenever you are doing any kind of analysis, make sure that you pick up the right model. Like if you go to the Google Gemma series, you will see that they have some models for healthcare. Then you have the model which is for code generation. Then PyGemma is for vision language processing, and Gemma is the kind of do everything generic based model. So pick up the right model for your use case. Try around with it based on your resource constraints if you are running them locally or on the GPU. Now, Tflan Fly is one of the models which runs directly on CPU, but it is lightweight and the output might not be that great. Gemma series runs well on a decent GPU, and based on your requirements, you can switch between different models. So that was the overall model selection part. Now let's jump into the code generation. So I am using a Google Colab notebook here, and the code that you see hasn't been generated by me. So for code generation part, you can use online code generator tools, like you can either use ChatGPT, you can use Google Gemini 2.5 Pro, or you can use Claude. So nowadays I prefer Claude, and this is the prompt which I use. That is, I wanted to create and analyze GitHub profiles. And initially I started off with Meta Llama 3 model, and then I switched to Gemma. So you can switch between any models that you want. And for user interface, I use Gradio. So the interface that you see, this clean interface that you have, that is created using Gradio library. So Gradio library is a great tool to create a user interface, interactive user interface in Google Colab. So you can either use Streamlit or Gradio based on your preferences. If you are running locally, I would prefer Streamlit. On Google Colab, the Gradio works in a better manner. So I use Gradio library for the user interface that you see here. So in the prompt part, I added that should use Gradio, and the requirement will be that I will add my GitHub username, analysis is written. So Claude generated this code for me, and this same code I have used in my Google Colab notebook, which we will go through step by step. So this was the first part where I was like creating the initial analysis. Now let me just jump into the code and show you the actual code itself. The first thing that we do here is we install the required packages. Now initially the packages weren't listed, so I asked Claude again that can you tell me the packages that I need to run this program, and these were the packages that it listed down. Now the versions had to be edited out because the versions were not working correctly, so I just like added pip install and then the version without the version names. Once that was installed, I realized that torch library wasn't working properly, so I added the command pip install update torch, and then torch vision had to be reinstalled again as well. So I installed a torch vision library as well. So this was the initial package installation part. Now if you are running this code locally, you should have a GPU, and you can either run it on Google Colab or you can run it on local machine based on what kind of configuration and GPU you have. Now for Google Colab, make sure that you change the runtime here. So by default the runtime is CPU. Make sure to switch it to T4 GPU because you need a GPU for running the Gemma models faster, and CPU will take a lot of time. Don't go for GPU runtime, go for TPU runtime, and make sure that you keep a tab on the resource usage here. So as you can see, the GPU usage is currently around 5.8 GB. Now I will experiment with Gemma models a lot, and I will come back to you which is the most resource optimized model. I haven't figured it out. I'm just starting out into this data science and LLM field, honestly. So currently I just use Gemma 1.1 because I thought it would be lightweight, but I will come up with a better solution as we move ahead with the future analysis and projects. So make sure that you track the system RAM because on free tier you have the runtime time which is allotted to you, and you need to be pretty like watched or observant about how much time you have, because if you run out of this GPU time you will have to wait for some time before the limit resets. Now it is not like a daily reset or something, it resets in a few hours, but make sure that you keep a watch on your runtime. Now I faced an issue where a few models like ran out of memory above 15 GB, and I had to switch to Gemma, which eventually worked. Now disk size is one thing which you also need to take care of, and system RAM is okay. System RAM doesn't get utilized that much. So that was the resources part. Now coming to the code part, we have imported the OS request JSON, then Gradio. Datetime is for the charting stuff. Toast library. From transformers, we are using auto model for casual LM, which is the library to use the model. Then for plotting the charts, we are using matplotlib. Datetime for datetime conversions. Word cloud is for the word cloud which we generated. Plotly is for the charts, again the bar charts and other charts that you saw. Pandas is for one of the data frame generation which I used for chart generation, and datetime is repeated again, that's okay. So first thing that we do is we check the device. So if torch.device CUDA is present, then we set the device to CUDA, or else we set it to CPU. In current runtime, the GPU is present. The next thing is to get the user data. So this is the API which I use. So get user info, and this API is like open API. And now if you like hit the rate limit in GitHub user API, you can like create an access token from GitHub account and add it here in the response request headers. And by that you have a much higher rate limit. Like I think there is around 5,000 requests per hour. By default, it will rate limit you if you like excessively hit the API. If you reach the rate limit of the free tier, make sure to add an access token and use the API using access token from GitHub API URL. You can search for ChatGPT on how to add the access token. Now you can get the username details from this API. Once you have that response, then the response is returned in a JSON format here. Similarly, the user repos are like fetched from repos API, and here again the username that we have passed. So around, in my case I had only 89, so they are returned in the first request as well. If you use a username from a bigger account, like let's just say Microsoft, which has larger amount of repos, then the first 100 will be returned. Then the repo languages is not much used, but you can also add the repo languages API as well. Now first thing that we do is load the model. So the model I just covered is Google Gemma 1.1 2B model. So this model, if you go to the model selection, so you have to copy the model from here, like copy this model and then paste it into your Google Colab notebook. So then this code is generated using Claude. You can just change the model ID to like switch between the models. Then the tokenizer is the library which gets the model or downloads the model. Now make sure that you have an Hugging Face token, because these are gated models and they will only be downloaded if you have a token. So just search for ChatGPT on how to create a Hugging Face token and add it to your Google Colab API secrets, and you can load them using os.environ. I am not showing my own token because for security reasons, but you can take that token and you can add it into your Google Colab settings, and then you can load the model. Then yeah, now the most important parameter here is low CPU memory usage. Set this to true. This is the most important thing, because without this there is a chance that the Google Colab notebook will run out of memory. Always make sure that you have this parameter turned on, which is low CPU memory usage. Device map is the whether you want to use a GPU or CPU. It is set to auto because it will let the libraries figure it out by themselves. Again, we have the auto model for casual LM, which will like load the model, then the token which Hugging Face needs, and the load config which we just saw, and this will load the model. So if you see the output below when I ran the code, so this is the model loading process, and once the model has been loaded, the model loaded successfully, message will be printed out. So model is basically downloaded. The safe tensors which I just talked about, they are downloaded here and they are like kept into the memory to be run using GPU, and that is the first step, which is the model loading process. Now let me just come back to the code. Then we have the generate with model, and with generate with model we have the tokenizer added, and we send a prompt to it. Now make sure that this input ID is sufficient or limited. If you are using, let's just say if you are using on a running this notebook on a less resources laptop or a instance where the resources are limited, then you can limit this input ID's length here. So there you can search for ChatGPT for limiting the length, and by that you will make sure that the resources used are a lot lesser than what they are required. Now this is useful when the resource is limited and you can like wait for some time for analysis to happen. So the more amount of input IDs you have, the faster the processing will be, but the more memory will be consumed. The lesser input IDs, the lesser number of resources, but it will take more time to generate the analysis. So you can limit this input IDs, then the max length is the way in which you can like limit it. Then there are other models parameters which I am honestly not aware of. I will research them in the future parts and I will tell you. Then we have the tokenizer.decode, which will like generate code, and this is a generated text from the model, and it is returned as generated text. Now there is a prepare GitHub data function in which we first fetch the data from the functions that we just saw. So you use the get user info which we saw above and get user repo. So these functions get the user repo and user info. Then we process the data, like we go into the individual repos and we take out all this information like name, description and other stuff, and we set them into repo info array or object. So basically Python or dictionary if you are using Python. And then it is appended into the repos info. And finally, this is the final GitHub data which is used into the prompt for analysis. We have the username, bio, the profile URL which we just saw in the analysis. This is from this profile and avatar URL, and the other stuff. Then the repositories has the information which we use for the charting purposes, and the repos info as the main object. Now this is the analysis prompt section where the actual prompt is getting generated. So we first take the top 5 repos, and the repo information is added into a string. And this is the actual prompt which I use for analysis. This is generated using Claude. So you are a Github profile analysis based on the below data provided analysis. So this is the profile information. Then this is the repo details which is passed to the Gemma model for processing. And this is the model prompt which generates the analysis. So we have the overview, the main technology, the development pattern, strengths and key technology and other stuff that is generated from the model. And then we pass this prompt to the processing and we get the analysis text in the function that we just saw. Now coming to the table that you saw here. So this was the analysis part. Now the table that you saw here, the code for that is present here. So we have a markdown table which is top repositories with star count title, which you see here. Then the table column headers are added, and then the table contains all the data. So we have like pass the GitHub data here, and from that the top repos are extracted out, top 10 repos sorted by star count, and they are shown in the table. Then we have the word cloud. So the word cloud that you see here, this is generated using matplotlib. So we have the word cloud library from which the word cloud model is used. We have the plt.subplot using matplotlib. We are taking the topic frequency from the GitHub generated data, and we are generating the word cloud. Then we have the bar chart based on the top 10 repos. Now this is generated using the plotly library. From this the px variable is present, and we also have a pie chart which is generated using again plotly library, and then a timeline graph is also generated using plotly. We had to do some processing here using the datetime library which was inputted at the top, and the year month in the data frame is generated. So this is where the pandas library was used for creating the data frame, and in the data frame we had to like group by the year month, and then we had to do some processing for which the pandas library was used. Then this is the main function which is the analyze GitHub profile, where we first take the username and we prepare the GitHub data from the above prompt. Then we create the analysis prompt and we pass it to the model, and the model generates an analysis. Then the repo table is created. All the charts are created here. Then the profile URL and avatar URL is passed. And this is the response that you see at the top of the page, which is the GitHub profile analysis that you see here. So this is the same text. We have the username, then we have the profile avatar URL, the profile URL, the address to the profile, then the analysis generated by the model and the repo table. And this response is passed back. Then the word cloud output and chart outputs are passed back to Gradio. Now Gradio interface is generated using the Claude model that generated this, and we have used like the Gradio interface in which we first like take the username input, then we have the analyze button that you see at the top here. So these are generated using Gradio. Then the output of the analysis is shown first. So this is the analyze button dot click method, which is the click handler, where the username is passed here, and these are the outputs from the model output. Then we have the analysis first, then the word cloud and bar chart, and the pie chart and timeline chart next, which we see after the table. And this is again using Claude. This is the main execution where we first check for the Hugging Face token, and then we show the output. Now one thing, as I mentioned, that Google Colab resources are limited. So whenever you are working on the analysis part, work on the analysis part. But once your analysis section is done, make sure to comment out the code when you are creating the charts. Why? Because every time you run this library or this code, the model will get loaded and it will keep on generating the analysis, because this is like the code is generated into a single file. It would be a better approach if I think now would to keep the analysis separate and chart generation separate, so that they are not mixed. But in this case, it is a single file which was generated using Claude analysis. But you can comment out the model loading part when you are working on the charts. Now it took me some time to generate the charts, so let me just go back to the Claude code generation and minimize the model selection. So the second prompt which I created on Claude was to help me create a word cloud generator first. So I copied this code into the Google Colab notebook and saw how the word cloud was generated, and then I pasted the code into the main file. Similarly, I created another prompt, like I wanted a few visualizations, and these visualizations that you saw, like the bar chart, the pie chart, they are generated using this third prompt. So this is the prompt that you can see here. So I used three prompts to generate. The first prompt was for the analysis part, second prompt was for the word cloud, and third prompt was for the other charts. So that is how the process in Claude code generation went by. And finally, we had the GitHub code analysis along with these bar charts. Now that was the code generation and model selection and model running part. And we have also covered the Colab code running. Now coming to the access of this Colab notebook. So I have open sourced this project on my GitHub profile. So if you go to this URL, which I will share in the YouTube description, you can find the GitHub repo in which there is a GitHub analysis Python notebook. And if you click on this Python notebook, all the code will be present here. So let it load for a while. So the libraries and all the code is present here. You can access it, you can modify it, and you can use it the way you want. You can optimize it and make it better as well. This is a like version 1 of the project. I was just new, so I created it based on my analysis. But as I go on learning, I will improve it myself as well. So that comes to the project access part. Also, there is a good README that you see here. So if you want to create README files like this for your GitHub projects, I have a README gen project from which this GitHub README was generated. You can access it from README gen version. Now, if you want to access these two tools directly, you can search for front-end vibes on Google. So this is my main website where we have the collection of all the learning resources which I have created till then. And if you like go below, you will see the GitHub Profile Analyzer section here. If you click on View Project, you will be redirected to the GitHub repo, and also the readme generator is present here as well. So you can access all the resources that I have created till now, and also play some games on this front-end vibes website. Just search on Google for front-end vibes, and this will be the first result. I will also share the link in YouTube description. So this was the model access part, and that was a quick demonstration of how to create this kind of workflow. So coming back to the quick steps, first is model selection. Always go to the official websites and search for it. I did not go to the official websites before creating the models, and that is where I think I messed up a lot and wasted a lot of time. Always go to the official docs because from there you will be like able to run the code in much faster. Then once your model is finalized for your specific analysis part, go to code generators like I will recommend Claude, or I think Google Gemini Pro is also good and decent for code generation now. But I prefer Claude because it gives me in detailed analysis and in detailed code, and the code exceeds the expectations which I generally have from the code generator tools. So I generally prefer Claude from Anthropic. So you can like, this is the official website, Claude.ai. This is from Anthropic's website. So you can use Claude.ai for code generation. Google Colab is a free tool in which you can run the code. Now I have an old laptop and my graphic card is pretty old, so I don't have an option to run this code locally. I am using Linux with a really old graphic card, and I don't. So I have tried running this code using Olama locally, but I failed, which is why I use Google Colab. And this will be my preferred workflow for future projects, which I'm going to run next. So stay tuned for that. And we have got the GitHub repo. So if you are a working professional, you can like use this workflow and create your own models. Now, an interesting example is Google Gemma is multi-model. So you can also do image processing. I came across a LinkedIn post where a person had created an OCR, like the model was able to recognize objects from the images, upload images, and answer the questions from the user. So Gemma model is multi-model, so you can use that as well. Gemma 3 is multi-model, and I'm going to try that as well. So for code generation, you have an optimized Google Gemma model as well. You can also use Llama models. So once you have the workflow ready and you have created those models locally, you can then open source them or deploy them somewhere and share it with others. If you are a student, make sure to open source your repos on GitHub because that will boost your chances. And make sure to have a developer portfolio where you can showcase these projects, just like I have on this front-end website. So this was briefly a long form video on how to use such models for analysis and then use existing data science tools for running a thorough analysis on any topic that you want. So yeah, that's it from my end for today. If you face any issue while running the Colab notebook, let me know in the YouTube comment section. I will be glad to help. And if you have any suggestions or feedback on how the video went by, kindly share it in the comment section as well. And like the video. If you haven't already subscribed to the channel, please do subscribe because I share tons of such useful content for free. All I need is for you to watch it so that I get motivated for creating more such content. And yeah, have a nice day ahead. Goodbye.